Now, let's dive in and know what is volumetric analysis. Volumetric analysis is a quantitative method used to determine the concentration of a substance by measuring the volume of a solution involved in a chemical reaction. It is commonly performed using titration, where a solution of known concentration reacts with a solution of unknown concentration. Volumetric analysis is widely used because it provides accurate and reliable results. Next, let's take a look of what is titration. Titration is a laboratory technique used to determine the concentration of an unknown solution. In this method, a solution with a known concentration called the titrant is slowly added to the unknown solution, known as the analyte. An indicator is added to show when the reaction is complete by changing color. The volume of titrant used is then measured and used to calculate the concentration of the unknown solution. Titration is widely used because it is a simple and accurate method of chemical analysis. Next, let's discuss why titration is used in making of wine. First of all, titration can help to measure the acidity of wine by determining its titratable acidity or TA. For example, a measured wine sample is placed in a container and sodium hydroxide was added slowly. The sodium hydroxide neutralizes the acid in the wine until the endpoint is reached, usually at pH 8.2 or when a permanent pale pink color appears. The more sodium hydroxide required, the higher the acidity of the wine. This allows winemakers to calculate the total acidity in wine. Secondly, titration also can help ensure wine quality, stability, and consistency by measuring the acidity of the wine. Proper acidity is important because excessive acids such as acetic acid can cause spoilage and unpleasant vinegar-like flavors. By using titration, winemakers can monitor and adjust acidity levels to maintain the desired taste and quality. It also helps improve wine stability during storage and ensure that each batch has a consistent flavor and aroma, providing a reliable product for consumers. Lastly, titration also can help detect spoilage and oxidation during wine production by measuring the level of sulfur dioxide in the wine. Sulfur dioxide protects wine from oxygen and harmful microorganisms. If a titration shows that sulfur dioxide levels are too low, the wine may be at risk of oxidation, which can affect its color, aroma, and taste. Regular titration testing allows winemakers to monitor sulfur dioxide levels and prevent spoilage and helping maintain the quality of the wine. For winemaking, acid-base titration is widely used to measure the acidity of wine. Acid-base titration is a laboratory technique used to determine the concentration of an acid or a base through a neutralization reaction. Example, to apply this acid-base titration in winemaking, sodium hydroxide is added to a wine sample until all the acids are neutralized. The volume of sodium hydroxide used is then measured to calculate the wine's titratable acidity. This information is important because acidity affects the taste, quality, and stability of wine. A wine with the correct acidity will have a balanced flavor, resist spoilage, and maintain consistent quality between different batches. Therefore, acid-base titration is an essential tool in wine production and quality control.
Now, let's talk about the theory of wine acidity determination. Wine contains several naturally occurring organic acids. These acids are fundamental to the beverage, providing its crispness, flavor balance, and ability to age. They originate from two primary sources, the grape themselves and the fermentation process. More than 90% of the acid found in wine grapes comes from these three core acids. First is tartaric acid, which is the most abundant acid in wine. It provides most of the tartness and crispness and is crucial for the chemical stability, color, and taste of the wine. Next is malic acid. Naturally present in grapes, this acid is associated with the taste of green apples. Lastly is citric acid, which can be found in a very small amount in grape. It adds fresh citrus notes, but is sometimes also used by winemakers to adjust acidity. During the winemaking process, yeast and bacteria naturally generate new organic acid. One of it is lactic acid. This acid is often converted directly from malic acid during malolactic fermentation. This acid is softer and creamier, giving wine a smoother mouthfeel. Next is succinic acid. This acid is a naturally byproduct of alcoholic fermentation. It imparts a slightly bitter, salty, and sour taste. Lastly is acetic acid. This is the most volatile acid in wine. While yeast naturally produce a small amount of it, too much is considered a wine fault. To determine the acidity of wine, an acid-base titration is used. This method is the standard method used to determine total titrable acidity. It measures the total concentration of free hydrogen ions and undissociated acids in a sample by neutralizing them with a standard strong base. A standardized strong base, like sodium hydroxide, is added slowly to the wine sample. The sodium hydroxide helps neutralize all the intrinsic acid in the solution. The endpoint of the titration is the point where all acids have been completely neutralized. This is typically identified using a pH indicator like phenolphthalein that change color, or continuously monitored using a pH meter. The target endpoint is usually a basic pH of around 8.2.
The main acid commonly used to represent wine acidity is tartaric acid, and the chemical formula is C4H6O6. During acid-base titration, react with sodium hydroxide in neutralization reaction. The balanced equation will get tartaric acid react with 2 moles of sodium hydroxide and produce sodium tartrate and 2 moles of water. This is the step of wine titration. First, the burette is rinsed and filled with 0.1 molar sodium hydroxide solution. Then, 10 ml of wine sample is transferred into a clean conical flask using a pipette. Next, about 20 to 30 ml of distilled water and 2 to 3 drops of phenolphthalein indicator are added. After that, the sodium hydroxide solution is slowly added from burette while continuously swirl the flask. The titration stops when a light pink color remains for about 30 seconds. It indicates that the endpoint has been reached. Finally, the burette reading is recorded and the experiment is repeated until the coordinate result obtained. The average volume of sodium hydroxide used is then calculated and used to determine the wine total acidity. This slide shows the calculation of total acidity in wine using a titration method. First, the number of moles of sodium hydroxide is calculated using the formula N equals to M times V. Using 0.1 molarity of NaOH and a volume of 8.5 milliliters, the moles of NaOH obtained are 8.5 times 10 to the power of negative 4 moles. Next, the balanced chemical equation shows that tartaric acid reacts with NaOH in a ratio of 1:2. Therefore, the moles of tartaric acid are half the moles of NaOH, which is 4.25 times 10 to the power of negative 4 moles. The mass of tartaric acid is then calculated by multiplying the number of moles by its molar mass, 150.09 grams per mole, giving the mass of 0.0638 grams. Finally, the total acidity is determined by dividing the mass of tartaric acid by the wine sample volume of 0.01 liters. The total acidity obtained is 6.38 grams per liter. Therefore, the acidity of the wine sample is 6.38 grams per liter.
In conclusion, volumetric analysis is an important quantitative analytical technique used to determine the acidity of wine accurately and reliably. In this study, acid-base titration was employed using a standard sodium hydroxide solution to neutralize the organic acids present in the wine sample. This experiment demonstrates that the volume of sodium hydroxide required to reach the endpoint is directly proportional to the amount of acid present in the wine. Through stoichiometric calculation, the total titrable acidity can be determined and expressed as grams of tartaric acid per liter of wine. Furthermore, the analysis highlights the significance of acidity in influencing wine quality. Appropriate acidity contributes to desirable taste, freshness, microbiome stability, and shelf life. Therefore, volumetric analysis serves as an essential quality control tool in the wine industry, enabling producers to maintain product consistency and ensure customer satisfaction.